mechanism of ionic bonding. Before starting the mechanism of ionic bonding, let us know what does mechanism mean. Mechanism basically represents all those steps involved in a process. Like if we talk of a chemical reaction, let us say N2 reacts to H2 and forms NH3. Here it is easy to write the equation as N2 plus 3H2 gives 2NH3. But if we observe that how this reaction proceeds to form NH3, then we will come to a conclusion that a number of steps have been involved in it. So basically, during any phenomena or any process, the number of individual steps involved, that is only the mechanism. So student, in case of ionic bonding also, which is a kind of process, so when the two species are attached to each other through ionic bonding, we observe that a number of steps are involved during the bond. Hence, we are calling it as a mechanism, and that we shall be observing in different steps. So for that, let us consider an example where we shall be dealing the ionic bond formation between the two atoms. So let us say Na solid plus Cl2 gas gives 2 NaCl solid. So let us check out that how a bond is formed between Na and Cl, that is how an ionic bond is formed between sodium and chlorine atoms. So very first step, in step 1 what we observe that solid sodium will be converted into gaseous sodium. Why it is happening? Because sodium being a metal should undergo the loss of electron, and as it has solid phase existence, it cannot lose electron, because in solid the particles are closely packed to each other, so electronic loss cannot be done. So very first thing which we observe is that solid sodium converts to gaseous sodium. Now it is quite evident that whenever we have to change the state of a substance, change the state of a matter, like here we are changing the state of solid sodium into gaseous. So in solid the particles are held to each other through a very strong bonding force, whereas in gas the particles are loosely packed, they are very far apart from each other. That means we are converting a substance where the particles are held through a strong bonding force to another state of matter where the particles are loosely packed. That means here the force are being decreased, the interactive forces are being decreased. So whenever we have to decrease the interactive force, we are supposed to provide energy. Means solid sodium on accepting or gaining energy will be converted into gaseous sodium. So here we shall be writing plus, plus means gain, Q heat. So it will accept heat energy and will convert into gaseous sodium. Now as here we are observing that the state solid is being converted into gaseous, means phase transition is taking place, and we can call this process as sublimation also. Sublimation is a process where there is direct phase transition from solid to gas or vice versa, and same thing we are observing here that solid sodium is converting into gaseous sodium. So the process is sublimation, and since heat energy will be absorbed during this process, so we are representing it by plus. For heat we are writing Q, and for sublimation process we are writing here S. So here Qs represents heat of sublimation. So in the very first step, solid sodium will absorb energy, that is heat of sublimation, and will convert into gaseous sodium. Now I would like to introduce here a new word. Sublimation is a word which is used frequently during the phase transition from solid to gas. But dear student, in chemistry, wherever we observe the state change or the phase change of an atom, like here also solid sodium is getting converted into gaseous sodium, so we are converting or changing or transiting the phase of an atom. So we can call the same process to be atomization, and the heat involved for this process will be called as QA. Here also QA is the heat of atomization. Now both are here the same. For this change they are the same. Atomization is a word used in case of the state change of an atom, whereas sublimation for any matter, whether it is in atomic state or elementary state or in the compound form, wherever a matter is undergoing the change or the transition of state from solid to gas, it will be called as sublimation process, and heat involved during this process will be called as heat of sublimation. Now in step 2 we shall be observing that the gaseous sodium will undergo the loss of electron, forming Na positive, and as already discussed that the positively charged metals after the loss of electron, they are called as cations. So here we have got sodium cation. Now remember this, that since electrons which are present in the valence shell of sodium atom are being taken out forming a cation, that means initially when the electron was present in the valence shell, it was held through an attractive force with the nucleus of sodium atom. That means when we are taking out the electron from sodium atom, the attractive force between the nucleus of sodium and the electron, that has to be made zero, and which can be done by the provision of energy. So we provide sodium gas an energy which is called ionization energy, such that it should be converted into sodium cation. Now here ionization, again plus why I am writing, because the system or sodium gas is absorbing energy to undergo the loss of electron from its valence shell. So we will be representing here positive sign before IE, which is representing ionization energy. So here basically ionization energy can be defined as, so ionization energy is the energy required to take electron from valence shell of a gaseous isolated atom. So here also in the step 2 we are observing that sodium is in the atomic state, isolated form, it is in the gaseous state. So on the provision of energy, that is ionization energy, it will undergo the loss of one electron from its valence shell, and in case of sodium it has got only one electron in its valence shell, so it will convert into sodium cation and one electron will be liberated out. Now in the next step, the electron which has come out from sodium atom will be added to chlorine. But remember one thing, that either removal of electron or addition of electron can only be done to an atom when it is isolated and in the gaseous state. Here we are observing that Cl2 is although gaseous but is not isolated, it is diatomic here, it's not isolated, so we cannot add electron of sodium into Cl2. So the very first step which will be involved here is that we will have to convert this molecular chlorine or diatomic chlorine into monoatomic, that is isolated state. So Cl2, which is non-isolated, will be converted into chlorine which is isolated. This is non-isolated, although it is a gas. Cl is isolated, it is also a gas. Now since we are separating two chlorine atoms which are held to each other, that means we have to overcome the force acting between those two atoms. Now to overcome the force, again we need to provide energy, and that will be called as heat of dissociation. We are basically dissociating the bond between two Cl atoms, so we are calling it as heat of, Q is heat, D means dissociation. Here plus sign will be used. Why? Because again we are adding energy to Cl molecule which is in non-isolated state to convert it into isolated form. Here Qd is representing the heat of dissociation. So moving on ahead to another step, that is step 4, we observe that chlorine, which is isolated as well as gaseous, will gain electron of sodium and will convert into Cl negative. Here as electron is being added to the valence shell of chlorine atom, means an electron which is isolated from the attractive force of the nucleus will now possess an attractive force, hence there will be loss of energy, and that energy is called electron gain energy, or we can call it as electron gain enthalpy. Basically enthalpy represent the heat content of a system, means energy, so we can call it as electron gain enthalpy or electron gain energy. So we shall be writing Q Eg. Here Q means heat, Eg means during electron gain. Since we had been using positive sign for the absorption of energy, here energy is being liberated, so we shall be using minus. Here Q is representing heat liberated during electron gain.